Come on, I'll teach you computer networking in 1 second. This is an IP address. It has 4 sets of numbers separated by dots, which is equivalent to your phone number. Below this is the subnet mask, which indicates the network segment of the IP address. It means that if the first 3 parts are the same, they belong to the same network segment and can communicate directly. For example, if you take 2 computers and connect them with an Ethernet cable, they won't be able to communicate with each other. You need to configure an IP address. For instance, set the left one to 192.168.1.1 and the right 1 to 192.168.1.2. Since the first 3 parts are the same, they can now communicate directly. This is the IP address configuration interface. The first field is the IP address, the second is the subnet mask, and the third is the gateway. We'll talk about the gateway later. After the configuration is complete, let's try sending a data packet from computer 1 to computer 2 to see what happens. As you can see, the data packet is sent to computer 2, computer 2 receives it and sends back a return packet. And once computer 1 receives that return packet, it means the connection has been successfully established. So, what is the point of this? For example, you can directly share folders to transfer files between computers, or enable remote desktop to control another computer. This is the simplest composition of a computer network. If a third computer comes along, it's obvious there's nowhere to plug it in. At this point, you need a switch. All computers connect to the switch, which allows multiple computers to access each other. Here, let's set the IP of the third computer to 192.168.1.3, and then use the second computer to send a data packet to it and see what happens. As you can see, the data packet is first sent to the switch. Since the switch doesn't know the destination MAC address yet, it floods the packet to all connected devices. The computer on the left sees that the packet isn't for it. Then, the third computer sends a return packet to tell the second computer that it has received it. So this is a local area network, LAN, on the same subnet. For example, in a school computer lab, 40 or 50 computers are all on the same network, which is why the teacher's computer can control all of your screens. Next, pay attention. I'm now adding a 4th computer and setting its IP to 192.168.2.1. Notice that the first 3 octets are different this time. So, can it communicate with the other 3 computers now? The answer is that they cannot communicate because the IP addresses are not on the same subnet. And this is because IP addresses are unique. If 2 computers have the same IP address, a conflict will occur, and the range for each part of an IP address is from 0 to 255. Therefore, if you want to communicate across different subnets, you must use a router. The function of a router is to allow communication between different subnets. Here, I'll add a router. The left port connects to the computer, and the top port connects to the switch. Then, we need to configure it. The IP for the left port is set to 192.168.2.254, and the top port is set to 192.168.1.254. This is the gateway address. Do you still remember the gateway address from earlier? For the computer on the left, fill in the gateway as 2.254, and for the other computers, fill in 1.254. This means that if you want to access other subnets, you go through your respective gateways. Let's take a look. Use computer number 2 to send a data packet. As you can see, it's first sent to the switch, which distributes it blindly as usual. Then the router receives it and sends back a return packet, at which point the link is established. Computer number 2 sends a data packet directly, the switch passes it directly to the router passes it directly to computer number 4, and then it returns along the same path. This completes the entire process. So, this is the most basic computer network. The video uses IPv4 addresses, but IPv6 will gradually become more common in the future. If you feel that configuring an IP for every computer is too troublesome, that's where DHCP comes in. This also explains why our phones and computers can be used as soon as they connect to a router. Of course, there are still so many network technologies that we haven't covered. If you're interested, we'll continue next time. That's it for this episode. See you next time.